यहाँ पे हम पॉज कर देंगे होगा, तो ये डबल लाइन दिखेगी पॉज करने के लिए, या रिकॉर्डिंग बस।
Hello students.
Yes, sir. Good morning, sir.
Today's topic is polynuclear aromatic hydrocarbons. Okay, polynuclear, as the name indicates, more than one rings when fused together, whether two benzene rings are fused together or three benzene rings are fused together, four benzene rings are fused together, then it is known as polynuclear aromatic hydrocarbon. Or we can say these are the fused ring hydrocarbons. And we talk about the naphthalene. Okay, naphthalene, how naphthalene is formed? When two benzene rings are combined together or fused together at ortho positions, it forms the naphthalene structure or naphthalene. And you see the structures. This is the orbital model of the naphthalenes, and this is the calculi structures of the naphthalene. And when two benzene rings are fused in, you see this. This is the ortho positions. This is the ortho positions. That is, these two benzene rings are fused together and form these naphthalenes. And numbering starts from clockwise 1, 2, 3, 4, then 5, 6, 7, 8. And this is the naphthalene structures. And molecular formula of naphthalene is C10H8. And we can manufacture a number of fused rings, that is polynuclears. For example, naphthalenes having the two fused rings of benzenes, and when three benzene rings are fused together, it forms the anthracene. And when four benzene rings are fused together, form pianthrene. Okay, but in our syllabus, only we discuss about the naphthalenes. And as you know, naphthalene is a component of the coal tars or petroleum crude oils. So that we can manufacture, we can get the naphthalenes from the coal tars as well as from petroleum crude oils. From coal tars, about 10% naphthalene presents in the coal tar. The middle while fractions having the boiling point 170 to 230 degrees centigrades, and these we separates the naphthalene by chilling the coal tars at this temperature 170 to 230 degrees centigrades. And when the crystal is formed, they are separated by centrifuging it. The crude crystals are melted and treated with the H2SO4 to remove the alkaline impurities, and it is washed with the aqueous sodium hydroxides to remove the phenols, which is remove the phenols and excess sulfuric acids. Phenols or crystalls are acidic in nature, so that we take the alkali for removal of it. And Finally, naphthalene is distilled to get pure naphthalenes. And we can manufacture the naphthalenes also from petroleum. The middle distillates of petroleum after catalytic cracking of naphthalene is obtained with the methyl naphthalenes. Means we do the catalytic cracking and naphthalene is obtained with the methyl naphthalene also as impurities, and it is removed or separated by dealkylation on heating at 600 degrees centigrade in presence of hydrogens. And you see the reactions, and I also send the uh, say I've sent the slides. You see, this is the methyl naphthalene. Two benzene rings fused together. This is the naphthalene structure, and methyl group is present. And by the dealkylations with the hydrogen at 600 degrees centigrade, we get the naphthalenes and methane is formed. So that we can separate the naphthalene, pure naphthalenes. And we can also manufacture the naphthalene from benzene. Benzene is treated with the succinic anhydride in presence of aluminum chloride. You see the reactions just below benzene. Benzene is treated with the succinic anhydride, and this is the aluminum chloride, and it forms the beta benzyl propionic. Beta benzyl propionic acids, and then it is treated with the zinc with mercury, that is the amalgam, in presence of HCl, and it goes under the reductions and it forms the gamma phenyl butyric acids. Then treated with the S2SO4, concentrated S2SO4, it forms the alpha tetralone, and after then zinc and after then zinc with mercury in presence of acids, it forms the terraline, and finally we get the naphthalenes. This is the another methods. This is a chemical methods we can prepare in the naphthalene in small scales. And properties of naphthalenes: physical, it can be divided to two parts: physical properties and chemical properties. Among the physical properties, it is a colorless, It is a colorless solids. Melting point is 80.2 degrees centigrade, and boiling point is 217.9 degrees centigrade. And it is very volatile in nature and sublimes slowly at room temperature. And this naphthalene is insoluble in water, moderately soluble in alcohols, and very soluble in ether and benzenes. Burns with smoky flames. These are the few physical properties, and among the chemical properties we discussed, first is halogenations. Naphthalene goes under the halogenation reactions with the chlorine or bromine, and you can see naphthalene when reacts with the bromine in presence of carbon tetrachloride after heating, we get the alpha bromonaphthalene plus HBr. And similarly, when it is treated with the chlorine in presence of carbon tetrachlorides after heating, we get the alpha chloronaphthalenes with HCl's. So that we get the halogenous end product that which is goes on at the first position, that is the alpha positions. And second one is nitrations. As you know, nitration is carried out by the HNO3 and H2SO4. These are the nitrating agents. When naphthalene warmed with the HNO3 and H2SO4 form nitronaphthalenes. Nitro group goes to the alpha position. So this is the formation of alpha nitronaphthalenes and waters. And there is sulfonation when naphthalene also goes to the sulfonation process. When naphthalene is treated with the sulfuric acid at 40 degrees centigrade, from alpha naphthalene sulfonic acid is formed, and at 165 degrees centigrade form the beta naphthalene sulfonic acids. There is a difference of temperature, means at 40 degrees centigrade approximate cold condition or room temperature, we get the alpha naphthalene sulfonic acids, and at high temperature, that is 165 degrees centigrade, it forms the beta product, that is the beta naphthalene sulfonic acids. You see the second is naphthalene at 165 degrees centigrade forms the beta product. And this also supports the Friedel-Crafts acylations. In the Friedel-Crafts acylations, naphthalene reacts with the acetyl chlorides and aluminum. Naphthalene reacts with the acetyl chlorides and aluminum chloride in presence of CS2 to give the alpha acetyl naphthalene. If nitrobenzene is used as a solvent, beta acetyl naphthalene product is obtained. You see in the chemical reaction, naphthalene treated with the acetyl chloride in presence of aluminum chlorides with CS2 at minus 15 degrees centigrade, and it forms the acetyl naphthalenes, and acetyl groups goes to the alpha position, so that it is known as alpha acetyl naphthalenes. And we get the beta acetyl naphthalenes at 25 degrees centigrade in presence of nitrobenzene. And reductions. The reductions of naphthalene with the sodium and alcohol forms 1,4-dihydronaphthalenes. And next one is oxidation reactions. Naphthalene on mild oxidations by chromic acids in presence of acetic acids form 1,4-naphthoquinone. Naphthalene goes under the oxidation process in presence of CrO3 in presence with acetic acids is formed the 1,4-naphthoquinone. And naphthalene in presence of air or vanadium pentaoxides after heating we get the phthalic anhydrides. And uses. Naphthalene used as a moth repellent. So that naphthalene balls are used in the woolen cloths to prevent from the moths. And it is also used as a insecticides. For commercial production of phthalic, it is also used for commercial production of phthalic anhydrides and for making the naphthols. And it is also used as intermediates for manufacturing of dyes, explosive and synthetic resins. So this is all about the naphthalenes, and next day we discuss about the orientation rule of benzene and naphthalenes, how they react with the different positions. For example, in the benzene rings, if we use any electrophiles, it go to the any positions from number 1 carbon atom to 6 carbon atoms. It forms the chlorobenzenes. Electrophile is chlorine, and when Cl2 reacts with the benzenes, one hydrogen atoms of the benzenes react with the chlorines and it forms the HCl, and chlorine goes to the any positions, it forms the chlorobenzenes. But when any group is present, then it create problems. Then it create problems. So, suppose we introduce the OH groups, that is phenols. When it becomes the phenols after addition of OH, then it goes to the ortho or para positions. It depends upon the nature of the groups. Groups are two types: electron donating groups and electron withdrawing groups. So that we discuss about these topics, orientation of naphthalene and benzenes, and in the next class how it goes to the ortho positions, how it goes to the para positions. Electron donating group goes to the ortho positions and para positions, means we get the two products. Ortho products, electrophile go to the ortho positions and electrophile go to the para position. So that EDG, that is the electron donating groups, gives the two types of products, ortho and para products. And electro withdrawing groups only supports the meta products, and we can discuss in the next class orientation rule of the benzene and naphthalenes. Okay, and send
Yes, sir.
okay, send the attendance on the WhatsApp.
Okay, sir.
इसको एक बार देख लेना, हम ये स्लाइड्स हम भेज देते हैं WhatsApp पे, ठीक है?
Yes, sir. ठीक, sir.
को कर दें क्लिक तो बंद हो जाएगा ना।
हाँ सर, एंड मीटिंग करते ही बंद हो जाएगा और रिकॉर्डिंग फोल्डर में ऑटोमेटिक सेव हो जाएगा।
रिकॉर्डिंग ऑटोमेटिक हो जाती है।
हाँ
अच्छा, रिकॉर्डिंग लिखा हुआ आ रहा है।
हाँ, रिकॉर्डिंग जो है ये कन्वर्ट हो गया, उसमें अपने आप चल जाएगी। ये नहीं, वो तो रिकॉर्डिंग जब दिखाएगा आप एंड करो मीटिंग।